Hello guys, and welcome to this third tutorial video of the Iris Dataset tutorial series. So in this video we're gonna proceed by building the model. Okay, so let us start by using the function tensorflow.keras.sequential, and in this this is the input layer. So the input shape should be the same as the number of features. So here it's 4 is equal to 4 to the number of features, and I chose the number of units to be 8. So the choice is more or less free, so it should be iterated, of course. And I also chose the number of hidden layers to be 3, and of course the number of the input shape should be the number of units of the previous layer. So here 8 is equal to 8 units, and then of course input shape of the third layer should be the same as the units of the second layer, and so on. And as for the activation function, so normally the best one is the leaky ReLU. Even the ReLU should be good as well, but it is more standard to use the leaky ReLU activation function. As for the output layer, so the number of units should be the same as the number of classes. Of course, the input shape should be here the same as the number of units of the previous layer, which is 8. And the activation function, as almost all the classification problems, we should use the softmax activation function. So for classification, the softmax activation function is best suited for being in the last layer, the output layer. Okay, so like this we built our model. Let us run the cell. Good. And then let us move on to compiling the model. So the optimizer, I used the Adam optimizers. So it is one of the best optimizer, but it's not the only one. But the loss function is the categorical cross entropy. So it is for classification again. It is the best suited loss function. So it is better than the other loss functions. Okay. So let us move on to training the model. So this is the one of the most important steps. So we use model.fit, xtrain, ytrain, and we chose the number of epochs to be 1000. So let us train the model. So it will take a little bit of time, and then here we are, the finished training the model. So the training has finished, and then let us plot the loss function. As we can see here, so the loss function decreases from almost 1 to almost 0 in the end of the training epoch, 1000 epoch. So normally we should expect to have a good performance on the training set, since the loss function has decreased to 0. So let us evaluate the model. So let us use the model.predict of xtrain to evaluate the performance of the training set. So here we can see that the values are not zeros and ones as we expect, but they are more or less close. So this one 9.99 power minus 1, so this is 0.99, so it's close to 1, and this is close to 0, since it's power minus 6, and this is close to 0. So yeah, so normally this should be good. But we should transform those values in order to be similar to the training labels, in order for us to be able to compare the performance of the model against the real labels. Okay, so for this we're gonna use normally we're gonna use a variable called train prediction integer in order for us to transform this train prediction here into zeros and ones. So, and we're gonna use the argmax. So let us see the output of this, and here we are. So now we obtain a format that is similar to the Y categorical that we talked about in the previous videos. So zeros and ones. Now we can measure the performance of our model on the training data. And boom, so 100% accuracy on the training data. This is very good. This is very good. But let us move on to the test data. Normally in the test data we should expect a little bit less than 100%. So let us use model predict on the test set, and similarly to the train set, we're gonna obtain the performance. It is 97.36, so it is very good performance. Not 100%, but still good one. So we have 100% on the training set and 97% on the test set, which is good. So let us now use another function to evaluate the model. So it is called the classification report. And here we are. So this is the result for the training data. It is 1, which means 100%. So all the 112 training data are correctly classified, correctly labeled. So this is good. And let us measure the performance on the test data. And now we're gonna see the F1 score is equal 97, which is almost 97%. So the zero here represents the setosa, which is the most distinguishable class. So it is correctly labeled, correctly classified as we expected. And then the performance on the two other species is not 100%, but it is close. Okay, so 95% for the second class and 97% of the third class. It's not a perfect classification, but it is very good. I think the performance can be improved. So this is guys the end of our video. If you liked it, please leave a like and consider subscribing for more videos, and see you guys in the next tutorial. Bye bye.